Let's have a look here. 4 kilogram object is moving across a frictionless surface with a constant velocity. That's important because that means what? Constant velocity means that the net force is 0 and the forces are balanced. That's what you're trying to say, right, Riley? Yeah. Constant velocity, the F net is 0. Which one of the following horizontal forces is necessary to maintain the state of motion? And the answer is 0, because objects in motion stay in motion. And many of you got that. That's good. Did you get that one, Colin? Did you? Oh, I can't check because I can only check the afternoon class. That's. Did he? Okay, so what did you get for number 2? What is the value of the friction force? A 20 kilogram box is gliding towards the right across the floor with an acceleration of 1 meter per second squared to the left. Many people wanted to do this. I don't know why. There is no applied force. It would have told you that there was, right? So the acceleration is 1 meter per second squared left. So this means that the net force is really, because the normal force and the FW are balanced, so the net force is really equal to the friction force. And that's it. That's the only force, right? And so if F net is equal to MA, which is mass 20 times, now it's 1 left, so I'm thinking it's minus 1. So the net force is minus 20, which should make the FF minus 20. Did you get it right? Yeah. Make sense, Taryn? Yeah, awesome. If the force is acting upon an object balanced, then the object, and I know for a fact that this exact question, almost worded exactly the same way, is in your notes somewhere. Force is acting upon an object balanced, then the object C must not be accelerated, right? Am I right? C? Yes, C must not be accelerating. It must be either, it must be at rest or moving at a constant velocity. My angle here is all wrong. Okay, what about this one here? A body of mass 15 kilograms rests on a frictionless surface and 30 newtons applied to it. What acceleration is produced? Oh, you guys all should have got this one right? I hope so. The applied force is 30. Mass is 15. Acceleration is going to be 2. They didn't get it all right. I don't know. This is the afternoon class. I can't tell. I don't know if I can save or not. Oh, I might be able to.
No, I think it's all 2. I'm pretty sure it's all 2.
Okay. How did you do here? I know one group had a lot of questions. 20 kilogram object will encounter a 50 Newton force, frictional force when pushed across the horizontal surface. With what force must you push the object in order to maintain constant velocity? I agree, Riley. It is easy. What's the answer? 50. Why is it 50? Because you have to balance friction. And is the word constant velocity important? Yeah. Oh, yeah. Oh, yeah. An automobile has a mass of 1,600 kilograms. What force required to give an acceleration of 1.2 if there are frictional forces equaling 200? Now, this one's a smidge harder. So we've got to figure out the net force. Mass is 1,600. The acceleration is 1.2. What's 1,600 times 1.2? 1,750? 1920. Okay, but do you just add or subtract the 200? No, you write the formula. We did an example just like this, right? F net is equal to FA plus FF. And so we get here the net force is 1920. The applied force is what we're trying to solve for. And friction is minus 200. When that goes to the other side, it becomes plus. So your applied force is 2120. Did you get that right? Do you think there'll be a question like that on the test? Oh.
More than one.
No, there won't be more than one. How did they do? Ooh. What will be its velocity at the end of 8 seconds? Well, we know it's acceleration of 1.2, right? So it would be A equals delta V over delta T. 1.2 is equal to delta V over 8. What does that work out to? 9.6? That sounds about right. 9.6 meters per second. And if the initial velocity is 0, then that means the? Exactly. Since VI equals 0, the final velocity is also 9.6. Are these starting to get easier for you?
Yep. I still got confused on 8.
Yeah? How far will it travel in 8 seconds? Well, the key with traveling is you need the?
Distance.
Well, yeah, you need the distance, but you need the average velocity because the formula is V bar equals D over T. But we don't have V bar yet.
No.
So we got to find it. Initial was 0, final was 9.6 divided by 2, so that's 4.53, 4.8. And now we go 4.8 is equal to D times 8. 4 times 8 is 32. 4/5 of 8, I don't think I can do it in my head. 32, what is it, like 36, 37? 38.4 meters, right? How'd they do? Only 7. Yeah. Okay, this is the hardest one you've seen so far, right? What is the acceleration of 1 decimal place of the object? The applied force is 50 at 25 degrees above the horizontal. Friction force is 5. Okay, I'm going to need a calculator. First step, find the x component, right? X component of the applied force. That's going to be FA times the cosine of 25. So that's going to be 50 times the cosine of 25. 45.3, right? And then we're going to find F net is equal to FA plus FF. .3, and that's going to be minus 5, giving me an F net of 40.3. And now F net is equal to MA. 40.3, mass was 10, giving me an acceleration of 4.03 meters per second. I think it said to 1 decimal place, but I guess it's not on your sheet?
No, it was on the whiteboard.
RC is 4.
Oh yeah, because 0 is.
I have to fix that. I remember saying that there was another answer on the sheet, but I guess I didn't notice that it was there. Okay, so are you feeling good? Feeling like, hey, I can do this. I'm ready for this test.
No.
Let's try it again. You feeling good?
Yeah, I got no bundle.
You can do it. We've been through all the problems. You've seen it over and over. I keep repeating. I guess.
You went through all the
I don't know.
Maybe we have to jobs for his daughter's last provincials.
Come on.
Now there's only 3 questions. You have 50 minutes. 50. That's more than 50 minutes per question.
I can't do this.
This is a pretest. You're going to hand it in before you leave. It's not going to take that long. And if you can do these, you're going to feel good about yourself. You should.
never eat
But, like, if I didn't, I would.
All depends on my mood time.
We'll be in a good mood then. She writes the, like,
Why don't you want to write them?
I don't know, I'd rather write like M equals 50.
Well, you can do that too.
like, but what I lose.
None of these, I think. The only ones where you really should probably do it, if there's like a horizontal component, add friction. I mean, once you get more than like 1 or 2 fourths, then you probably should.
Okay.
Yeah. There's no real hard and fast rule on friction.
Okay.
I'm gonna do my test.